This is the sum of an arithmetic series formula in the yellow box. So imagine you have an infinite geometric sequence and you want to find out what would it approximately add to. A few things you have to take into consideration is that R value has to be greater than -1 and less than 1. Here would be our formula. And you'll probably recognize that a sub 1 is the first term, and then the common ratio is r. So here's our example. Find the sum of this infinite geometric sequence. So it doesn't actually stop. So we need to find the value of term 1. So here is your term 1. 3/8. And then you have to find the common ratio. So from previous lessons, the common ratio is you take any term and divide it by the previous. So I'm just going to take term 2, which is -3/16, and divide it by term 1, which is 3/8. So what we have here is a fraction divide another fraction. So we're going to keep the -3/16. We're going to change this to multiplication, and then we're going to flip the denominator to 8/3. Now before we multiply, I suggest that you do any reducing of common factors. So you can reduce by 3, and then you can reduce by 8. All right, so now we're ready to multiply across. So -1 times 1 is -1. 2 times 1 is 2. So the common ratio is -1/2. So now we're going to go ahead and use our formula. So the sum of this infinite sequence, the value of term 1, is 3/8 over 1 minus the common ratio, -1/2. Now let's simplify it. So the numerator I'm going to keep as 3/8. The denominator, negative and a subtraction, is going to turn that to a plus. And then 1 plus 1/2 is 3/2. So we have 3/8 divided by 3/2. And now we're going to keep, change, flip, reduce. 3's will cancel to 1. 8 and 2 have a common factor of 2. So you reduce that to 1/4. So the sum of that infinite geometric sequence is 1/4.